Hello everyone. In today's video, I will be going over the second part of the absolute value notes. This section is 1-2 and it's over absolute value inequalities. For all real numbers a and b, b is greater than 0, meaning b must be positive. The following statements are true. This hint box here is something we will give you on the quiz, and it shows you how you're supposed to set up your problem. Once you get this setup down from the box, the solving is up to you. So as long as you know how to solve these problems, you will be just fine for your quiz. Also, you might notice that this first half here is different. I did go ahead and type it up differently, but I did show you guys this way in class. If the absolute value of a is, reminder, this is less than b, then a is less than b and a is greater than negative b. So that's what you're going to set up and solve this here. If the absolute value of a is greater than b, then a is greater than b or a is less than negative b. So the things to really take away from here, what we're doing is when we're writing the first new inequality, it's the same as the original. We just drop the absolute value. And then to get the other one, we flip the sign and change the sign on b, make it negative. And then you do the same for the greater than. Drop the absolute value for the first one. For the second one, flip that inequality sign and make b a negative. These statements are also true for less than or equal to and greater than or equal to, respectively. So you'll set them up the same way, just make sure if it has that or equal to that you include that. Before I start solving, I want to show you a mnemonic device I use to help me with these problems. If you have greater than, I want you to think of it like this, and this is going to be intentionally misspelled. Greater than. Since it's greater than, you should have or in your answer, just like you do here. Less than, we pronounce as less than. So you should have and in your solution. This is a way to check and make sure that your work is correct. This will make more sense once you see a few problems. Number 1, the absolute value of x is less than 8. So the first step for these is to make sure your absolute value is isolated, which it is here. It's just on the left-hand side. So this is a less than problem, less than. We need to have and. So when I split it up, I'll drop the absolute value and I'll have x is less than 8 and x is flip the sign greater than, make it a negative, negative 8. To check our work on these problems, instead of plugging in numbers to see if it works, that's a bit of a pain because with these types of problems, you can have so many answers that work. So it's better to check with a graph. So we have our number line here, and I have 8 and negative 8 as my answers here. So I'm going to put both of those on the graph, 0 in the middle. Reminder, 8 is to the right of 0, negative 8 is to the left. If you misplace those, you'll mess up your answer. We have no or equal to here, so we're going to have open circles on both of those numbers. Now remember, this trick I'm about to show you only works if x is on the left-hand side, so just remember that. X is less than 8. It's pointing to the left. So from 8, I'm going to draw this arrow to the left. And x is greater than negative 8. Notice it's pointing to the right. This sign is. So from negative 8, I'm going to draw an arrow pointing to the right. And notice that there's a nice overlap here. That means it's an and graph, which we should have because it matches our and statement. That works. So this is our answer. X is less than 8 and x is greater than negative 8. I want to explain conceptually what this statement means here with the absolute value of x is less than 8. So yesterday we talked about when absolute value of x equals a number. I'll show you real quick. So for example, we had the absolute value of x equals 10. That means the distance between 0 and x was exactly 10. So that means x either had to be negative 10 or 10 for it to be 10 from 0. Here we have a range of values because of the less than. So really what this is saying is that x is less than 8 units from 0. So the distance between x and 0 is less than 8 units. So x has to be less than 8 and negative 8. It's going to be somewhere in between here. Every single number between 8 and negative 8 can go in here and it'll work. Number 2, let's see with an actual equation. Reminder, the first step is to make sure that your absolute value is isolated, which we see that it is. It's on the left side by itself. So now we make our two equations. When we do the split, remember, think about whether this should be an and or an or. This is a less than sign, so less than. It's an and statement. So I'll go ahead and write and here. And then I'll make my two equations. 2x plus 4 is less than 8. You keep it the same. And 2x plus 4 is, now we flip the sign, greater than negative 8. Flip the sign and change the sign on 8. Now I have two equations. I'm going to solve them. They'll be solved the same way. Subtract 4 on both sides. 2x is less than 4. Divide by 2. X is less than 2. And solve one more time. Subtract 4 on both sides. 2x is greater than negative 12. Divide by 2. X is greater than negative 6. So these are the two answers that I got. Now let me graph them and make sure they work. So I'll check. So my numbers are 2 and negative 6. So I'll have 0. 2 will be to the right. Negative 6 will be to the left. Still open dots. X is less than 2. It points left. X is greater than negative 6. It points right. Notice the overlap. This is an and graph, which we should have. This is an and statement. So this works. This matches. So that tells me that this is my answer. I'll rewrite it one more time. X is less than 2. And X is greater than negative 6. Now let's take a look at an OR problem. The absolute value of x is greater than or equal to 6. Our absolute value is already isolated over here, so we can go ahead and make our two inequalities. With the greater, that's going to be an OR. So I'll have something or something. Drop the absolute value for the first one. X is greater than or equal to 6. Or x is, flip the sign, less than or equal to negative 6. No solving to do, so let's go ahead and check. Make our number line. 6 and negative 6, 0 in the middle. 6 on the right, negative 6 on the left. That or equal to tells us we are going to have closed dots. Then graphing the arrows, x is greater than or equal to 6, it's pointing right. So I'm going to draw the 6 arrow going to the right. Or x is less than or equal to negative 6, this is pointing to the left. Notice there's absolutely no overlap or any kind of meeting between the two arrows. This is what an OR graph should look like. which matches our OR statement. So that's what we should have. What this means on the graph, I'm going to explain this like I kind of did with number 1. X is at least 6 units from 0. You could also say X is 6 or more units from 0. So, as you can see, the shortest distance that we can have here is the 6. After that, it just gets further and further away from 0. So that's what this is saying here. If this doesn't quite ring true for you, that's all right. Not a huge deal. As long as you can solve the equations, we're good to go. So this would be my answer. Now let's solve another equation. Absolute value of negative 2x plus 7 plus 5 is greater than or equal to 14. First step. And you'll notice that this is very similar to the process we did yesterday with 1, solving absolute value equations. The process is very similar, a lot of the same steps. Step 1 is to isolate your absolute value. This has not been done for us. We need to move this 5 over. So we'll subtract it on both sides. Absolute value of negative 2x plus 7 is greater than or equal to 14 minus 5 is 9. I'll stop here because I can see that my absolute value is now isolated. So this is the point where I can split it into 2 equations. Before I do that, I want to figure out and or. This is greater than or equal to, greater, or. So this is an or statement. Now I'll bring this down. Just drop the absolute value for the first one. Negative 2x plus 7 is greater than or equal to 9. Or negative 2x plus 7 is, flip it, less than or equal to negative 9. Now I can solve. Subtract 7 on both sides. Negative 2x is greater than or equal to 9 minus 7 is 2. Divide by negative 2. This cancels. X, 2 divided by negative 2 is negative 1. Notice I divided by a negative here. If you remember, that means that you flip the inequality sign. So this becomes a less than or equal to. Now let's solve the other one. Same steps. First, we'll subtract the 7 on both sides. Negative 2x is less than or equal to negative 16. Divide by negative 2. X is, flip the sign, greater than or equal to positive 8. So these are my 2 possible values of x. X is less than or equal to negative 1, or x is greater than or equal to 8. Let's check it with the graph. We want an or. On the graph, I've got negative 1 and positive 8. So I'm going to put 0. 8 is to the right. Negative 1 is on the left. We've got the or equal to in both of them, so we're going to have that closed circle. X is less than or equal to negative 1 points to the left. So I'm going to draw the negative 1 to the left. X is greater than or equal to 8. It's pointing right. So I'll draw 8 to the right. Hopefully you can see that this is an or graph. It's pointing away. And we had or in our statement, so that works. So our answer, x is less than or equal to negative 1, or x is greater than or equal to 8. All right, we've got 2 more problems on the back. Notice it says other possible solutions here, so that should already tell you that something's going to be off about these problems. So I'm going to just solve them like normal. First off, make sure Your absolute value is isolated. Notice that it is not because of the negative 2. Remember, we're not going to distribute that in. We're going to get rid of it. Since this is like multiplication, I'm going to divide it off on both sides. Bring down absolute value of x plus 5 is less than 10 divided by negative 2. Actually, I just made a mistake here. 10 divided by negative 2 is negative 5. Since I divide by negative, this will actually be greater than, yeah, that's convincing, greater than negative 5. Now that I've got this isolated, I can make my two equations. Make sure you ask yourself if this is and or. This is greater than, so or. First equation, I'll just drop the absolute value. X plus 5 is greater than negative 5. Or x plus 5 is, flip the sign, less than, changes to a positive 5. Solving for x will be very quick. Just subtract the 5 over. X is greater than negative 10. Or subtract the 5 again. X is less than 5 minus 5, 0. Now we check. I have negative 10 and 0. 0 will go on the right, negative 10 to the left of it. X is greater than negative 10. This is an open circle because we don't have that or equal to. And that symbol is pointing to the right. Or x is less than 0. Again, another open circle pointing to the left. Now notice we got an and here. If I look back at my problem, I had or. That's what I wanted, but I got and. That's not good. When this happens, you have one of two scenarios. Now this is assuming you've done all the work correctly. So I haven't made any mistakes here. This is how the problem will come out. If this happens, then you've got one of two possible scenarios. You either have all real numbers for your answer, meaning that x can be anything, or you have no solution, meaning there's no answer to the problem. It's just no solution. There's no value of x that will work. So what you do, let me back up here. This I call a mismatch. Graph and answer do not match. They should both be and or both be or, not one of each. So what you need to do is go back to the inequality before you split it up. So this one here. Absolute value of x plus 5 is greater than negative 5. Don't go back to the original. Go back to the one right before the split happened. Now you need to look at this and you need to ask yourself, is this always true? Or always false? It is going to be one or the other. So let's look at this and think about it. We have the absolute value of x plus 5 is greater than negative 5. So just to give you an idea, we essentially have the absolute value, which is always positive, is greater than a negative number. So I'll write positive number greater than negative 5. Now that if we write it like that, is that always true or always false? Hopefully you're thinking always true because that's the correct answer. A positive number is always going to be bigger than negative 5. The smallest possible thing I could get out of here is actually a 0, because 0 is not positive or negative, it's considered neutral, but that's still bigger than negative 5. Any other number is going to be positive because you can plug anything in here, it's going to come out positive. If you don't believe me, or if you get something like this and you're not sure, you can always test a number. The easiest number to plug in at all times is 0, so let's do that. 0 plus 5 is greater than negative 5. 0 plus 5 is 5. Absolute value of 5 is 5. 5 is definitely greater than negative 5. It works. If you don't believe this, say you're like, well, I don't see it. If I put a negative in, that's going to change everything. Then pick a really big negative number to put in there. It's still going to come out positive because of this absolute value. That's not going to make a difference. But if you haven't convinced yourself yet, try it with a few other numbers that you think would not work and show yourself that it does work. Since this is always true, that means that every number I put in for x works. So my final answer is all real numbers. Last problem, number 6. The absolute value of x plus 4 minus 5 is less than negative 8. Again, step 1 is to make sure you isolate your absolute value. That has not been done yet because we have to get rid of this negative 5. So I'll add it over. Bring down that x plus 4 is less than negative 3. I've got it isolated, so this is the point where I can split it up. First things first, we need to figure out, is this and or? We have a less than symbol right here. So this is going to be and, less than. Now I'm going to create my equations. Write the original as is without the absolute value. X plus 4 is less than negative 3. And x plus 4, flip it, is greater than positive 3. Solve for x, it's just one step. Subtract 4 on both sides. X is less than negative 7. And x is greater than negative 1. Now we check. Make sure you're careful about this. When it comes to negatives, a lot of students get confused, so think about it for a moment. Which number is smaller, the negative 1 or the negative 7? Hopefully you thought negative 7 because that is correct. Negative 7 is smaller than negative 1. It's more negative. So make sure you put them in their correct places. And then I can add in a 0. Actually, no, I can't. 0 does not go there. 0 is all the way over here. What was I thinking? Ignore that. All right, so now we have open dots because of the less than, no, or equal to. This for negative 7 is pointing to the left. And for negative 1 is pointing to the right. Hopefully you can clearly see that's an or statement. But we needed to have an and. So again, we have that mismatch. When that comes up, we go back to the equation we had before we made the split. So x plus 4 is less than negative 3. Again, you have to ask yourself, always true or always false? Absolute value of x plus 4 is less than negative 3. So here we're saying that a positive number, because again the absolute value always comes out positive, is smaller than negative 3, which is a negative number. Hopefully you look at this and immediately feel like that is incorrect. It is incorrect. This is never going to be true. A positive is always bigger than a negative. So this is always false. Again, if you're not convinced, you could easily put a number in here. You could put a 0 in here. You would get 4 is less than negative 3, which is not true. So that's something you want to do. Feel free to do it. Since this is always false, that means there is not a single value of x that will work here. Not one. They will all fail. They will all make this untrue. So that means we have no solution. And that's that. Another thing to point out, notice with both number 5 and 6, Notice I've got the absolute value isolated. The number on the right side is negative. Same thing with 5. Absolute value on the left, negative number on the right. Those are indicators that these are either going to be no solution or all real number problems. So if you notice the negative at first, then you could jump to the conclusion here by looking at it, thinking about it. I would advise that you be careful with this though, because a lot of students will just see a negative number and it maybe this isn't isolated yet, something like that. That's not necessarily the same thing. If you're afraid of messing it up, there's nothing wrong with doing the work. It will just take you a few extra minutes to do that. Lastly, there's just a summary of the graphs at the bottom if you need to reference any of those. That's all the notes I was going to cover for today. If you have any additional questions over the notes, feel free to either see me in person or contact me via email. Otherwise, I hope you have a wonderful day. Bye!